Thanks, everyone. Yeah, I'm Brandon. I am a software engineer here at Knewton. We don't write a lot of Rust, but what we do write, I've written. This is going to be a talk about software engineering, really enterprise grade, and specifically how I've integrated Rust features into building large programs. So, quick question: how many people here have written at least 100 lines of Rust? How many people here have written at least 1,000 lines of Rust? How many people here have written at least 10,000 lines of Rust? All right, I think we're getting to the point where I know my audience. So for some of you, some parts of this will be really interesting, and for others of you, those same parts will be fantastic and interesting. So, as professional software engineers, we do not like writing spaghetti code, am I right? Yes. Mild agreement. But what we do like is writing well-layered architectures. So, lasagna. Oh, turn the lights a little bit. No one here knows how to do that. Thank you. Thanks, McVeigh. We do like writing well-layered architectures. What are the things about spaghetti that we do not like? We do not like untraceable paths, looking at a block of code and having no idea what it does. We don't like the lack of separation, looking at code and really having no idea why it's where it is instead of somewhere else. We also don't like having dunked everywhere, variables that have no reason, and etc. Contrary-wise, Lasagna provides a pretty good model for code. Lasagna is big and flat and easy to use. There are tools in place, aka the pasta itself, to keep the layers separate. And also, the layers in lasagna continue interacting, because otherwise it wouldn't do anything at all. Interestingly, as I was writing this slide near the end of my talk, I discovered that lasagna code is an existing term of art for poorly structured code. But ironically, it was too well integrated into my talk for me to. So I'm going to talk about most of the ways that I maintain a Rust project. I'll start with a simple project and talk about growing it and using more and more features to increase the abstraction and privacy guarantees. To do that, we need a project, something to walk through, to grow, to maintain. And I'm going to use a cache because I love caches. They're one of the simplest things to implement, and they're also probably the worst thing because they always go wrong, and you always end up wanting some other feature on top of your cache. So I think they're a good model for software in general. Code. When writing a cache, the obvious thing to do is to just use a hash map. Just like, I've got too much data, it takes me a long time to construct my data, so I'm going to check before I operate on it, before I build the data, whether or not I've already computed it. The concept here is pretty straightforward probably to everybody. You check whether or not your cache contains something, and if it doesn't, you put it into cache and then you do stuff. The idea here is that you can do the same thing twice and not do expensive stuff. So this is pretty trivial, but it does have something kind of interesting in it. Even on this crazy simple thing, you get to see some of the beauty and pain of Rust. This API requires a mutable reference. That means that even if you are just looking at the definition of this function, you know that it is going to be possibly mutating this hash map. That is awesome when you are just reading code, trying to figure out what's going on with it. Even though this kind of looks like line noise, if you're pretty much all the time, you still are actually getting real information out of this. And when I'm interacting with Rust APIs, every time I feel the pain, every time I don't know, I have to restructure my program. I need to add a reference to something that I thought I could just duplicate. I try to think about the fact that the users of my code, which is like probably going to be me, realistically, are going to be grateful about the fact that every API describes what it's actually doing, and I try to lean into that as much as I can. So using the features instead of just sort of muttering about mud. So what's the next thing that we could possibly do? We could abstract it. Like the thing that we care about, the function before, this block of code right here, all we're doing is we're getting or inserting the items from the cache. So in 1958, Fortran invented functions. Actually, I don't know who invented functions, but that was when Fortran got functions. And we can abstract this a tiny bit. We can take a cache map. We can take a cache. We can do other stuff with it. I'm going to start first of all, talking about mod. Mod is really, really straightforward. It is how you isolate code. It is the fundamental and most important privacy barrier in Rust. As the fundamental and most important privacy barrier in Rust, it serves the same function as files in C, classes in Java, and underscores in Python. Modules are also the smallest unit that can be broken out into their own files. I often, when I realize that a file has gotten too big, I will start abstracting it by creating a module inline like this, just sticking some curly braces around a bunch of code and adding the mod keyword in front of it and just fixing things until they look good. This is super lightweight. It means that after I've spent somewhere between 5 minutes and 15 hours fixing this module, I can extract it into its own file, and it costs me nothing. And if it didn't work, then reverting is super trivial. Also in this talk, I'm going to be exclusively using the 2018 edition because it is better. Crate is a keyword in the, crate as a visibility modifier in the 2018 edition is a visibility modifier means that your entire current crate can view the item that you are applying it to. So the fact that I've got the word crate, there means that I can call that function somewhere else. It is similar to the package private modifier in Java. I'm not really familiar with very many other languages that have a similar expose this to everything. I'm sure that it's everywhere. It is also very similar to underscores in Python. K and V are generics. They're just generic generics. They define a type that will go into the map. They are not always better than C++ templates. They are better than Java generics. The important part for my purposes is that they function as another form of privacy barrier. The way in which they are superior is that they sort of adhere to the concept of composition over inheritance. You can sort of create your own folksonomies of constraints when you are interacting with traits. Instead of, like some other languages, being required to create a can insert into hash map type or hash key, you can just say that the hash maps require hash plus heck. This is pretty great because Rust doesn't actually have the type level facilities to create a can insert into hash map type. So not many people are annoyed by that right now because of the fact that traits are powerful enough that we can sort of ignore the fact that the type system is not as sophisticated as we would like it to be. Yeah. That's it. Another property here is that, like I said, modules are the fundamental privacy barrier. The fact that this has no visibility modifier on it means that nobody outside of this module can see it. The fact that private is the default is fantastic. Don't make things public unless you absolutely need to. One of the reasons that Rust tests are often written inline is because it is possible to access private members. Keep things private, don't make them public, and you will be much happier. That's just what I just said. So that is a ton of sort of intro level syntax for Rust. Everyone agrees that Rust has kind of a bumpy learning curve. I've touched on a couple of things. And the main thing that I really want to take away from what I just said, all the stuff, is that Rust provides a lot of tools to make sure that the things that you are explicit with your APIs. So you can, like, everything that you do is intentional and can be made intentional. So it's possible to write extremely explicit, terse, and clean APIs in Rust. More pasta. The next step in our humble cache is going to be to add another layer of encapsulation, because what we've got so far does not make it super easy to pass things around. So we're going to pass it around. This looks very similar to the last one, but what is actually new? Yes. We have created a crate struct cache, which is just another layer of encapsulation. You'll see that it is still inside of my module cache, my cache module. It still has got a visibility modifier, and it also exposes its inner workings to the outside world. So the fact that we have a crate modifier on its internal types means that in the same way that a public item in several other languages would be accessible from outside, they're outside here. This is a totally acceptable decision in my point of view. It is reasonable when you are starting and growing an API to just, when you trust your users, expose the guts. Doing this means that you don't need to write a bunch of code. You don't need to write an API around it that enforces any kinds of invariants. You don't need to duplicate the entire HashMap API just to make a little bit, just to get something off the ground. It means that you are capable of adding APIs that make it trivial, that make your use case clear, but it also means that you can be lazy. Laziness might bite you, but it also means that you can make a lot of progress much faster. Another interesting thing here is that we have moved the generics from the function to the struct and impl. That is because it is impossible to construct a hash map that does not have the hash neck constraint. So we need to know that there, which means that if we're going to have it on the, if we're going to have that constraint on the cache, then we just need to have that everywhere. So the Rust compiler is going to enforce that the things that you do make sense and propagate outward correctly. A subtle but awesome part of Rust's impl blocks is that they do not need to match the constraints on the object that the type that they are implementing. The cache requires hash plus ek, but the impl cache only requires hash plus ek plus clone. It is a superset. You can have multiple impl blocks, even bare impls, for types without needing to, with different constraints, determining whether or not those functions are available to you. You'll get compile time errors if you screw up and try to use something. The compile time errors will probably be pretty bad. So it's a trade-off. They're actually a lot better than when I first started writing this talk, so that's kind of awesome. In this particular case, you could create a cache that has keys that do not implement clone, but you won't be able to use any of the utility methods that you're defining. Oh yeah, here we go. like I said, you will get compile time errors. This is, I created a wrapper type. This is the new type pattern. If you hear people talking about it, it is just it's a new type that is exactly the same as an unsigned 64-bit integer, except for the fact that it has none of the implementations of an unsigned 64-bit integer, so you'll be able to add or anything. The only thing that I implemented for it are hash and ec, and that means that when I try to get or insert with this item, I get standard clone is not implemented for wrapper. It doesn't tell me that that is specifically because of the requirement on the cache, but so it goes. There's only one more thing that I want to talk about at this level of abstraction, and that is that private functions inside of implementations are still module public. So this ensure exists even though the function get or insert is public to the entire crate. Ensure exists is not. It's only available to the module. So I said that everything that we had done was reasonable, assuming that you trust your users. We don't trust our users. I want to introduce an environment that requires that we do not, that we maintain the invariant. Which means that we don't want to let people just mess around with our inside hash. This means that new is a function that all of a sudden we need to create. Like we didn't have to create a new, we didn't need to write this code before, but now we do. But to make sure that we have a reasonable API for our cache, let's get rid of this ugliness. A hash map, the cache itself doesn't actually have anything to do with the metrics that we're tracking on it. It's completely reasonable to want to create a cache and not track metrics. The reasons that you will be changing your cache implementation and cache API are completely different from the reasons that you would change your metrics API. One's going to be business and one's going to be performance. So let's create a new struct, cache metrics, which takes a cache inside and etc. We've got a nice, clean separation of concerns now. The big benefit here is, of course, that the cache module and the cache metrics module are going to be a lot simpler to understand. And sort of interestingly here, we have got a design that sort of speaks to Rust's commitment to a couple of fun sentences that like to get thrown around, which are pay only for what you use and zero cost abstractions. If you don't want to use cache metrics, we've designed this in a way where you don't need metrics, so you don't pay for the cost of checking whether or not you hit something. But also, if you do use cache metrics, this cache is just going to be inlined. You aren't going to have any kind of performance hit for deciding to, well, it's fairly likely that the optimizer will optimize out all of your wrapped methods. So you're pretty likely to end up with an essentially free wrapping layer. You're only going to be paying for the extra metrics that you're requesting. That's just kind of trivial. It doesn't, basically, you just shouldn't need to worry about modifying your API. But we have got this new import, which we haven't seen anywhere before. So let's look at what happened. We've got an enum cache insert. Insert if missing is now using it. For some reason, insert if missing is now a public function. If you were awake a little bit before, then you might remember that insert if missing used to be entirely private and used to return nothing. So now we're doing this. The cache implementation is ignoring that return value. So what's going on there? It's a mystery. I've got stock images subscription accidentally, so it's not a good mystery because I described what we'll be doing. But it was briefly a mystery. Cache metrics obviously needs to know whether or not it is, whether or not it succeeded on its insert. So we needed to push this, change the API of this internal type. I just said that it was good because that separating these two things was good because the reasons that the items will change are different. And here I am saying that we will create that we change the type specifically for this thing. I would argue that this is good. If you are changing your APIs, the APIs should be changing in one direction. The direction here is we want to, users of the cache may have extra needs for it. So changing the API because of dependencies or because of wrappers using it is totally acceptable. Changing your APIs, if the cache metrics API started changing because of the cache API, then we'd have, like, if the push was going in both directions, then there would probably be a problem, and we'd have a bad separation there. We have now done a ton of work, and we can talk about what the core components of our cache are. In this case, that means that we're going to build a trait. This is fairly late in the talk for us to be starting traits. I typically try to think of traits as coming in as late as possible and no earlier. That's because traits, just like encapsulation, add a layer of complication, and you just want to keep that until you know what you're actually doing. The main thing that would cause me to implement traits earlier than because of like direct production reuse is testing. Sometimes you just need traits to be able to mock out fairly heavy dependencies like the internet or databases or something. But in general, just like abstract-based classes in Python, which I don't think uses that, or interfaces in Java, which literally everybody uses for everything. It's reasonable to delay actually writing traits. So what does a trait look like? It looks like an interface. You've got a function, you've got another function, you've got a function that uses those functions. Just like in languages with abstract-based classes, some functions can be defined in terms of other functions inside of it. We added another function, another method for the purpose of writing this utility method. It's fairly common to say, give me one or two, like ideally, when you're writing a trait, you will be able to write it in such a way that people who implement it only need to implement one or two methods to get like a whole bunch of cool functionality. If you're writing something like this. If you're writing a database abstraction, like literally every method is going to need to be implemented. But why do we have clone here? Clone was here because when I originally wrote it, I needed clone to the methods that I was extracting actually required clone, but this is a trait. It doesn't need clone. Don't do that. One nice thing about Rust is that removing trait constraints is like fully backwards compatible. You're never going to get a compilation error because you said that my code is more flexible. Traits are they're entirely public. They're interfaces, so the only visibility modifier can go on the trait definition itself. Implementing cache is straightforward. You write impl cache for cache. This is now exactly where we were 5 minutes ago, and it's just not exciting. I mean, as I just said, you don't actually need to that are missing. Here we have done the thing that I suggested we were going to do, where the implementation actually requires clones, so we have propagated clone everywhere. In this particular, yeah, that's it. So now that we've got a trait, we can create a cache metrics that can take any kind of cache instead of just the cache that we wrote. This is pretty awesome. It looks exactly right. It doesn't work because of the fact that the generics don't actually show up in the type in the struct. You will get a compilation error if you don't try to use phantom data. As far as I can tell, phantom data only exists as a kludge for situations like this. Sometimes Rust will say that you don't, your trait bounds do not appear in your struct, and then you just stick the phantom data in there. If someone knows of a reason that is not a kludge to use phantom data, please talk to me afterwards. All right, cool. I'm going to ignore it for the rest of this. Implementing a cache for cache metrics is trivial. It's exactly the same as before. We've defined the item. We write insert of missing it differently, et cetera, et cetera. We write with. Finally, we have some dependency injection. Software engineering. I promised to use software engineering. And the cache constraints continue. Minor point about Rust style functions or any different namespace to values. It's common to not have the get prefix that you see in other languages. That's that. Overall, I probably could have skipped the last 5 minutes of this talk. It's exactly as you would expect it to be. It's pretty obvious. Implementing an interface is just writing the code to do it. But we now have a trait, which means that we've had to write all this extra code, and it's generic. This is what it looks like when you tie it all together. It's sort of what you would expect. Everything that we just did got us this sweet line right here. So now we've got a trait. What can we do with it? We can create an any cache, which is a boxed-in cache KV. We had that question during the raffle about what happens when you stick a trait inside of a box, and the answer is vtables. It's an even more abstract cache. This is anything that implements cache can be stuck inside of any cache. Types are not new types. This is a type alias. This doesn't get you any sort of compile time guarantees. All it does is make it easier for you to write the word any cache instead of boxed in cache KV. But we do use it all over the place, so I escaped myself. This is a little weird, though. The cascade cache, which is what we are building, it's a cache that can cascade back through multiple layers of cache, has a first and a rest parameter. The first is an any cache, and the rest is more any caches. The reason that I did this is because Rust's testing is complicated and sometimes very difficult. And so I try to make as much stuff get enforced by the type system as possible. A cache that has no caches is not a cache. Requiring a parameter to be present because of the fact that Rust does not allow null values, it does not allow partial construction of objects, means that all of the code can assume that that a cascade cache has at least one cache, and we don't need to test that. We need to test other things, but the compiler will. It's kind of fun. This also uses the builder pattern. We create a cache with some cache, and then we can add more caches to it. So we can do with a cache and any more caches that we'd like. This is what it looks like. We have now successfully created cache metrics that have a cascade cache that take a box of caches, and then for some reason do another cache. So we have successfully doubled our memory requirements with, and halved our performance for no. What about building an ecosystem? What makes an ecosystem? One of the things that is very useful to think about is depending on your purposes, the scale of the objects or the scale of the library that you're creating and how widespread and disconnected the users are going to be. So, for example, open source or a gigantic company, it sometimes makes sense to extract the very bare minimum to a core crate, so that that thing has absolutely no reason to change, and the entire ecosystem can depend on its stability. This is getting used more and more in the Rust community. There's a few popular crates that are doing this kind of thing. I just said both of those things. The other thing is publicity. You first of all need to allow items to be used from outside of your crate. This is the first time in this talk, unless you're paying a ton of attention, that I actually used the pub visibility modifier. Pub should be used in the 2018 edition to actually export items from your crates. Otherwise, you should be using some sort of more limited form of publicity or visibility modifier. The big benefit there is that it is super obvious what things are actually part of your public API. It also means that crates are more meaningful. It means that crates have a simple public API that should be as limited as possible. Yep, intentional APIs, that's what I said. Oh, look, this is the slide where I realized I had no diagrams. So the idea here is that you create a cache, some sort of core crate. You can implement that crate in a variety of other crates, and then your application can use it. And you can use it in any way you want, and et cetera, et cetera. That's it. That's all I got.